Now we have our segment on the top 10 most important and famous amusement parks in the world. Number 1 being Phyz-Land. Land of physics.
Are you looking to find physics in your daily life? Are you trying to have some fun while on your scientific quest? Well, Phyz-Land is just the place for you. From rides that explore potential energy and kinetic energy, gravitational force and normal force, friction, to mechanics of a pendulum, and much more, you'll be able to identify and apply many rules from the physics classroom.
We have our first ride, the thrilling roller coaster, Death Trap. Roller coasters at an amusement park must deal with potential energy. The possible energy stored that can be achieved based off of position. At the top of the loop, the roller coaster has a greater potential energy based off the height of the drop. With the equation mgh, this is easy to calculate for potential energy. The other option is the energy of motion, aka kinetic energy. The greater the mass and speed of the roller coaster, the greater the kinetic energy it will have. As the roller coaster travels down the decline, the potential energy is converted to kinetic energy. Kinetic energy will be greatest at the bottom of the first cell, and potential energy is the greatest at the top of the first cell. The roller coaster must have enough mechanical energy to climb up a sequential hill after a drop. The forces of air resistance and friction impair its movement. Friction between the train and the tracks, as well as between the train and the air, take energy out of the system, slowing the train and creating both heat and sound. The mechanical energy cannot be conserved, but the first drop must always be the tallest. Roller coasters upside-down loops also explore the laws of physics. At the top of the loop, the acceleration is directed towards the center of the circle. Gravity and acceleration forces push the passenger in opposite directions with a nearly equal force, creating a sensation of weightlessness. At the bottom of the loop, the gravity and the changing direction of the passenger's momentum form a downward vertical direction, and the passenger feels.
Where A is centripetal acceleration, B is velocity in meters per second, and R is the radius of the circle in meters. This means that the higher the train's velocity, the greater the centripetal acceleration. This also means that the smaller the curve of the path being traveled, the greater the centripetal acceleration. Because of this, many high-speed roller coasters use banked turns rather than the flat ones that are safe for slower speeds. Banking the turns in a roller coaster gives you the feeling of being pushed into your seat rather than being thrown to the side of the car.
There's a simple carousel named the Galloper. Uniform circular motion is seen in carousels, where the entire circle has to complete the ride at the same time. Therefore, the outer part of the carousel has to travel faster to cover the same amount of distance in the same amount of time. The acceleration of a carousel is directed inwards, and the velocity is tangent to the carousel.
A difference in mass and velocity will also affect the collision. Total momentum is conserved in all collisions. Rubber cars are classified under inelastic collisions because although the objects bounce apart after the collision, kinetic energy is lost due to friction, heat, and sound. The equation for this is m1v1i plus m2v2i equals m1v1f plus m2v2f. And it's the equation that can be used to calculate for either mass, velocity, or change in kinetic energy. Rubber bumpers increase the time of the collision so the same force applied does not cause as much damage. The momentum impulse theory is the equation used, mv equals ft.
Our next ride is the Elevator, a turbo drop ride. If you love gravity and acceleration, then this ride is just perfect for you.
Video.
Turbo rides descent faster than free fall, or in other words, 9.81 meters per second squared. The ride exerts a force back on the rider, and therefore a force of negative g is experienced. The strong downward thrust does not last for more than a few seconds. After the initial instant's downward velocity, the acceleration slows down and becomes more constant due to the factor of air resistance and friction from the free fall.
Who doesn't love a good pendulum ride? On a pendulum ride, the greatest acceleration is experienced at the ends of the ride, where the ride will need maximum force to change direction. Potential energy is also the greatest at the ends since the height will be at its maximum. The fastest velocity will be experienced in the middle of the ride, where kinetic energy is the maximum as well. A strong force of gravity is experienced on a pendulum ride mainly due to the seat. Since gravity acts downward and the centripetal force is acting towards the center of the ride, at the bottom of the circle, an upward force will be needed on the rider, which is provided by the seat. To calculate the period of a pendulum, you would use the equation t equals 2 pi times the square root of L over g.
The Ferris wheel is a classic amusement park ride. Our Ferris wheel, called the Spin-O. The wheel is rotating in a vertical plane, carrying the person up one side, over the top and down the other side to the bottom at a constant angular speed.
The last exploration of our Phyz-Land is the water gun rides, a simple amusement park game. Who wants to win a stuffed animal? First, you have to learn a little physics. The physics of projectile motion is key in mastering these games. The greater the angle of launch, the shorter the range. A height of 90 degrees yields the greatest height but no range. The horizontal component of the velocity will always remain the same if air resistance is neglected. Well, it's been a great educational ride. We hope you visit Phyz-Land soon.
From rides that explore potential energy to kinetic energy. I messed it up. Oh no, I didn't. Go.
Everyone loves
Are you serious?
You're recording.
Yeah.
We'll drive some more cars.